Alrighty, so now our next example is explosion in one dimension. And from our previous video, we saw that the formula for explosions were here. So we have we have an initial mass with an initial velocity, and then that breaks off into two separate pieces. Is what we're going to work with in this case. So an explosion, so it doesn't always have to be a bomb. So we can consider Cordelia, who has a mass of 55 kilograms, and Anne, who has a mass of 50 kilograms, together on an ice skating rink. They push each other apart, and Cordelia recoils with a velocity of 2 meters a second. What is Anne's recoil velocity? Okay, so we consider them one mass beforehand, and then they break off here. They break off here into two masses, going their separate ways. Okay, so if we were to write the equation down, it's the mass, the initial mass with the initial velocity, is equal to our second mass with its final velocity, plus our third mass with its final velocity there. Okay, so initially it is, what does it say? So they are initially stationary. Okay, so that means that we're going to have their combined mass times 0, which equals 0. We have a mass of 55, and we're going to say that that way is positive, so we'll give this a negative 2 meters a second. And we add that 50 mass here times by that final velocity. So 55 times negative 2 is negative 110. Then we bring it over to this side. So it's 110 is equal to 50 times by V3. So therefore, V3 is equal to 110 divided by 50, which is equal to 2.2 meters per second. And it's going in the opposite direction of Cordelia. So opposite direction of Cordelia. Okay. Good. So not too bad. Got one more example problem, and you might be happy to know that this is extension work and not for examination, so two-dimensional problems. For those of you wanting to do physics in year 12, then you'll do more problems like this. But if we think of this like an example for a vector problem, we will still have to do that. So we can just consider these momentums as vectors. So we have a vector here and a vector here. And then we're more than capable of solving those problems. Okay, so we have two cars. Car A has a mass of 800 kilograms and car B has a mass of 1,000 kilograms. They collide and coalesce, which means stick together. Alright, and this is probably a good time to remind you all that you can take a dictionary into the exams as well. The velocity of car A before the collision was 10 meters a second north, and that of B was 5 meters a second west. What is their combined velocity after the collision? Alright, so rather than just going straight into a velocity diagram, because they have different masses, we have to consider their momentums instead. So over here, we've got our vector triangle. So this was our vector north, and then this one here is our vector west. And then P is the resultant vector. And we have to remember that we need a direction. And so that's what this angle inside here will give us. Alright, so we have, we can find P by using, so we can use P we can use Pythagoras theorem to find P here. Okay, so we have 5,000 squared plus 8,000 squared. So we get those values from here from calculating their momentums. And that is equal to 9,430 kilograms meters per second. Okay, so that's the unit for momentum. And to find the final velocity, okay, because that's what it's asked for, what is their combined velocity after the collision, we have to divide, so P is equal to mv, and they have a combined mass of 1,800 kilograms. So then we have a combined 9,530 is equal to 1,800 times by its final velocity. So therefore V is equal to 9,430 divided by 1,800. And if I grab my calculator, just pause this video. Okay, so that is equal to 5.24 meters per second. Okay, but because it's a vector, we need to have a direction as well. And so theta is equal to tan to negative 1 of, we have 5,000 over 8,000. And that angle is north 32 degrees west. Okay, so that's our final velocity there. Final velocity of 5.24 meters a second, and the angle is north 32.